Okay. So finally, I want to get to the third type of equation. We're going to go over it very quickly because it's actually a lot simpler than what we have been dealing with. And this type of simpler equations is actually what you are going to be doing also in your project, right? Okay, so for Poisson's equation, we are looking at the second derivative plus f is equal to 0. If you want to introduce also a second derivative in y, it's basically the same analysis, right? So you can do it also. Well, let's actually do it a little bit more complete analysis here. Let's actually make x and y derivatives. So basically what you have is you have x, you have y, and you discretize the space into spacing that is spaced over delta x in the x direction, delta y in the y direction. So the approximation is going to be the same. Is going to be the approximation of the second derivative in space is going to be, now I have two indices, right? So if I have I delta x over here, and well, delta y, 2 delta y, 3 delta y, so these are these locations. So this is going to be wij. So the second derivative is wi plus 1 plus wi minus 1 minus 2wi, but I always copy the index j. And now the derivative in y is going to be wij plus 1 plus wij minus 1 minus 2wij divided by delta y squared is going to be equal to f of ij, well, plus fij equal to 0, right? So fij is the value of my function f at I and j. Okay, so now by just applying the finite difference operator, I'm not converting my equation into an ODE. What did I convert my equation into? Oh, I converted directly into equation I can solve in computer without ODE 45. I converted it into a set of linear equations. Okay. Now for the Poisson's equation, I have to know the boundary condition at all the sides. Okay. So for example, if I know the value of w is equal to 0 at all the sides, I equal to 0 and I equal to n, and j equal to 0 and j equal to m. So let's say the right of the domain is n equal to 1 over delta x. Let's look at a square domain for now, and you can deal with other domains. You can generalize to other domains pretty easily. Then that means I have how many unknowns? My unknowns are going to be I equal to 1 to n minus 1 and j equal to 1 to n minus 1, right? So I have n minus 1 times m minus 1 unknowns. I have as many equations because for every I and j, I can plug into this equation, while the boundary conditions are dealt with by directly substituting the values of I plus 1, I minus 1, j plus 1, or j minus 1 at the boundaries. Okay, so let's go into Matlab and try to do this. Let's try for a simple case where fij is always equal to 1. Okay, so let's see how do we do that in Matlab. So let's close all and make it clean. Okay, so n, let's give me a n to use. 10, okay, that's pretty small. M, do 20, okay, so just to make them different. So my delta x and delta y, they are both equal to 1 over n and 1 over m, okay? And So here, the first thing I need to do is to form these equations into a linear system. And before I do that, I have to order my unknowns. Right now, my unknowns are in 2 dimensions. I now have to order them into a 1-dimensional vector. So let's start with W11, W12, W13, etc., all the way to W1. Yeah, M minus 1. Yeah, and then I'll do W21, W22, etc. Right? So basically, I loop over the 2nd dimension and then the 1st dimension. So you can order it in different ways. Actually, some people who are familiar with different programming languages seems to be like to order them in different ways, but it doesn't really matter as long as you are consistent. Okay. So this is how I order my W's, and now if I want my right hand side to be the same way, F11, F12, etc., F1, M minus 1, and F21, etc., how should the matrix be? Well, to construct the matrix, you actually look at each of these equations and figure out where are the non-zeros and what the values are. For example, W11 should be multiplied by what to get to the corresponding, well, actually it's actually plus this equal to 0. Let's make it that way, it's a little bit easier so that we can plug in terms. W11 is going to be multiplied by what if you look at this equation? It has 2 terms, right? The corresponding one has this guy and also this guy. So what should be here is this actually minus 2 minus another 2 over delta y squared. So that's the 1 term. Okay, how about W12? W12 in this equation, the first equation we are looking at is the equation I equal to j equal to 1, right? So W12 is actually corresponding to Wij plus 1. So the second number we should plug in is this guy, right? So it's actually 1 over delta y squared. Okay, how about the third one? Nothing, right? Because the equation does not depend on j plus 2. So okay, so all the way up to the, so here we have a block of m minus 1 numbers, but starting from the mth number is different because now I'm multiplying by Wi2. So at that point, I need to now find the one corresponding to Wi plus 1j, which is this, right? At this point, I have 1 over delta x squared. So that's how I find the first row. Okay. And now, okay, so now again, what's the right-hand side? The right-hand side is also not going to be 0. So for I and j equal to 1, the right-hand side consists of the numbers that I already know, which is all the numbers I didn't circle in the differential operator. Right, so all the numbers I didn't circle, let's just use green, is actually, well, let's also make it plus something equal to 0. So all the numbers I didn't circle include W0, 1 divided by delta x squared plus W10 divided by delta y squared, right? So these are appearing here and here that I did not circle. So now I complete the first equation. The second equation, again, let's start from the red. On the diagonal, on the 2 entry is the same. It's the same as the 1 entry. So it's this guy, right? Let's make it a little bit bigger. Okay. Then on the left hand side, I have multiplied by W11, right? Remember, this is I equal to 1, j equal to 2. So W11 is actually Ij minus 1. So in order to fill in the ij minus 1 term, so I get now this term is now part of the unknown as opposed to part of the known, right? So otherwise I have the same thing, so I have also now ij plus 1, and when I get to the black term is now over here. It's a little bit further on the right. So we have to really careful go through the exercise to figure out where each term is. Okay, so with this, let's actually start to code it up in Matlab. Okay, so what we find out is that if you go through the analysis carefully, is that we have a pentadiagonal structure. So all the numbers in the first block is going to be lying on the diagonal, and one row above the diagonal and one row below the diagonal. And also we have another block. We have also the blocks are also organized into a tridiagonal structure. Okay,